Hi again. I know the quality of my last video was a little poor. I zoomed in so that you can see my writing a little bit clearer, and I'm going to get a microphone so that the audio is better quality. Right now, the audio is just being recorded by the little microphone inside my computer, so do the best you can. If there's anything that you can't understand or if you have any questions, just email me and I'll try my best to clarify. Otherwise, I will get a better microphone going forward. So we're going to do the instructional video now. I recommend having your logarithm properties out next to you. You could put them on a note card or on a separate piece of paper just to review them really quick. They say log base b of m equals log base b of n, therefore m must equal n. Log base b of m plus log base b of n equals log base b of m times n. In other words, you can condense addition by multiplying. Log base m minus log base b of n equals log base b of m over n. I kind of messed up on that one, but you get the point. You can condense a subtraction problem by dividing the arguments. And then log base b of m to the p power, that p gets pulled out front and becomes a coefficient, and in other words, you're multiplying those two terms together. Okay, so these are the four logarithm properties. You used them to either expand or condense. Today we're going to be using them to solve logarithmic equations. So today's the 16th, solving logarithmic equations, and we're just going to jump right into it. So in this case, we've got two logarithms set equal to each other, and we have a missing variable. We have an x. So we're going to use those logarithm properties to solve for x. First thing I noticed, they don't give us an explicit base on either side here. We know that if they don't give us an explicit base, we are to assume we're working in a base 10. It's called a common log. Don't necessarily have to memorize that yet, but we can assume if there's no base to assume it's 10. Okay, so this is actually referring to property 1. It says that if two logarithms are set equal to each other and the bases are the same, which they are, then we can assume the arguments are the same. So if I confirm that the logarithms are equal, the bases are the same, I can drop the entire logarithm and set the argument equal to each other. Hopefully this sounds familiar. It's really similar to the exponent rules. If we say that 5 to the second power equals 5 to the x power, we can confirm that the bases are the same, drop the bases, and set the exponents equal to each other. So it's really similar to the exponent rule that we worked with earlier in the week, or earlier last week, I should say. Okay, so we've got the arguments set equal to each other, and now we just solve for x. Subtract 2x from both sides. 3x equals 9, and x equals 3. Okay, that's about as easy as it gets. It does get tougher. I'm going to go one step tougher every problem. Okay, problem 2 reads negative 10 plus log base 3 of n plus 3 equals negative 10. Negative 10 plus log base 3 of n plus 3 equals negative 10. Okay, so we are going to apply logarithm rules here, but the rules of algebra still apply. We're adding together negative 10 plus a log. So in order to get this n isolated, I'm going to start by just getting rid of that negative 10 by adding 10 to both sides. That leaves us with log base 3 of n plus 3 equals negative 10 plus positive 10 is 0. Okay, so there is no logarithm property that tells us what to do when we have an addition symbol in the argument. If you think back to your logarithm properties, what you have here is a multiplication symbol that's expanded with an addition. We can't use an addition and expand it to multiplication. That's not how it works. What we can do, however, is recognize that every logarithm can be rewritten as an exponential expression. My base is 3, my exponent is 0, and my argument or answer is n plus 3. And now we just have a simple algebra problem. Anything raised to the 0 power is 1. Subtract 3 from both sides. N equals negative 2. Final answer. So again, one step tougher. They're going to get tougher every step of the way. Number 3. Number 3 says log x plus log of 8 equals 2. Okay, we're going to confirm that the bases are the same. They are both 10 in this scenario. And then we do have a logarithm property that tells us what to do when we're adding together two logs. When you add together two logs, you can condense them by multiplying their argument. Log of x plus log of 8 is the same as saying log of 8 times x. Now I can rewrite my logarithm as an exponential equation. Your base in this case, we're going to assume is 10 because it's not otherwise given to us. My base is 10, my exponent is 2, my argument is 8x. Now we just have a simple algebra problem. 10 squared is 100. Divide both sides by 8. X equals 100 over 8, 50 over 4, 25 over 2. I believe your answer key gives you improper fractions, not decimals, but if you do get a decimal here, just convert it to a fraction and check against the answer key. Okay, we're going to do one more. This is about as tough as it gets. This is number 4. Let me switch my pages here. Number 4 is log base 6 of x plus 1 minus log base 6 of x equals log base 6 of 29. Okay, first of all, confirm that your bases are the same. They are. If your bases are not the same, the log properties do not apply. They're not going to trick you. They're not going to give you a problem where the bases aren't the same, but it's a good idea to confirm that. You cannot apply the properties unless the bases are the same, so it's just a good habit to get into to confirm that they are. Okay, so I'm going to start by applying my logarithm property for subtraction. It says when you're subtracting two logarithms, you are allowed to condense them by dividing their arguments. And in this property, the argument of the first logarithm becomes the numerator, and the argument of the second logarithm becomes the denominator. So make sure that you're writing them in order. X plus 1 over x equals log base 6 of 29. Once again, we can confirm that the bases are the same. And if we have two logarithms that are equivalent to each other with the exact same base, we can assume the arguments are the same. Okay. So I'm going to solve this algebra problem. I'm just going to start by moving the x to the other side, multiply both sides by x over here, so that my x's cancel out on the left-hand side. We have x plus 1 equals 29x. Subtract x from both sides. 1 equals 28x. Divide both sides by 28. X equals 1/28. Final answer. Okay. I lied. I'm going to do one more. This one, well, whatever. I'm just going to jump right into it. There's one more tougher step. Don't panic, just to apply the rules that you already know. If at this point in time you get the hang of it and you want to just try your homework, stop me. That's fine. Your homework is going to be only 2 through 22 evens on the section that says logarithmic equations. I'll go over that once again when I'm done with this problem. Last one, number 5. 3 log base 5 of x minus log base 5 of 4 equals log base 5 of 16. Okay, so I like this problem because it requires that I apply two log properties. The first one says that if you've got a coefficient here, you can assume that at one point in time, this was the exponent of your logarithm. So I'm going to rewrite that log base 5 of x to the third power minus log base 5 of 4 equals log base 5 of 16. And then I can condense my two logarithms here by dividing their arguments. We've got a subtraction problem, and we can turn subtraction problems into division problems. Now, hopefully you're kind of starting to see the pattern that emerges here. When you're left with a logarithm on both sides with the same base, you can go ahead, drop the log, and just focus on the argument. Okay. Multiply both sides by 4. X cubed equals 64. take the cube root of both sides, x equals 4. All right, guys, that's it. Once again, your homework is logarithmic equations, 2 through 22 evens. So you've got the front side evens, and then on the back side through 22 evens. Ignore 24 and 26. Once again, we're going to talk momentarily about what that means. It's called the natural log, but that is for another day. All right, good luck. If you have any questions, email me or post to Classroom.